So in this tutorial we're going to look at how to make your player interact with the background. That's called background collision. You can see in this game from the GameBoy quirk I can move around, but actually I can only move one tile at a time. It's doing some animation in between them, but it's stopping me going sort of 1 pixel. Same with Pokemon here, I can move a whole tile at a time. And this makes your game much easier to program if you do it this way. The user still thinks they can move because you've got this animation, but actually they can only move one tile at a time. And it makes a lot of the code you're going to have to write a lot simpler to do. Now there are some games that do it a little bit cleverer. So Final Fantasy, for example, lets you move half a tile at a time. It still means you can get through doors that are 1 tile wide, and it's obvious that why you can't get through. But if you make it only 1 pixel, it can be really tricky why a player can't get through. Zelda also does this really well, where you're kind of halfway and could almost make it. If you push down, it will kind of snap you around the corner automatically, so it realises you want to get out the door. So this is a really advanced way of letting you move a tiny bit, but still managing to get through doorways. So that's what we're going to look at today, show you the code for that and get a basic example up and running. Let's get going. So in this tutorial we're going to be building on many of the skills you've learned in the previous videos. If you haven't seen those previous videos, I'd really go and watch them first, because I'm going to zip through the bits we've already done so we can get to the code for today, which is going to be quite long anyway. So for this game I've already designed a sprite, so I've got my little snail sprite here, but I've also got some sprites for my background, so I've got my maze sprites. So I've got an empty sprite at the top here, I've got a stone, I've got a door, and I've got a key. And if we look at GameBoy Map Builder, you can see I've used the stone here for the outsides of the walls. I've got a key down here and a door here. So like we have in the previous videos, we just need to export this map out, export the sprites for the background out, and export the snail out as a sprite for my games. So that's what I've done. Let's get stuck into the code on that. So as I said, we've got a lot to cover in this tutorial, so I've actually already created a basic project that loads in all those assets. So I'm loading in the maze sprites, which is the block and the door and the key, and the map for that. I've loaded in my snail character. In my main, I'm loading in the background data from maze sprites. I'm loading in the background tiles between starting at 0 and 0 and going to 20 and 18, which is the full size in sprites of the Game Boy screen. And I'm loading that from maze maps. That displays my background, those two. Then I'm setting some sprite data, so the from 0 to 1 from snail, creating a sprite 0 with the 0 sprite that's in sprite data as the sprite. And then, as you've seen me using in other videos, I've got a uint member variable called player location, which is an array with 2 ints in it, basically for x and y. I'm setting that to 16 and 24, and I'm moving the sprite initially to that location. Then I'm showing sprites and showing backgrounds, because we're using both today, and turning the display on. And then I've just got a simple, like we've done in some of the other ones, a simple while loop that lasts forever. And if I'm going left, I take 8 off the player's X location and then move the sprite. If I'm going right, I add. If I'm going down, I'm minus from the Y. If I'm going up, I'm minus from the Y, and if I'm going down, I add to the Y. So you've seen this done hundreds of times, hopefully, in the tutorials I've done previously. And then we're calling performant delay, which I've introduced in the last few videos, which is just a method that doesn't tax the CPU too much, but puts a bit of delay in between you pressing the button and the next one triggering as well. So if we load that, you'll get this. You'll see my snail is here. Now it may confuse you, and it's also confusing me at the moment, that we set the location of the player to be 16 and 24. I don't understand what the coordinates are doing in GBDK for this, to be honest. I would expect that position there, the top left, to be 8 and 8, because it's 8 pixels in and 8 pixels down. There seems to be some offset going on that I can't quite figure out. So you'll see in the code today that we have to deal with that offset. So effectively 16 should be 8 and 24 should be 8, so we'll have to deal with that later. But I can now move my character around and he will move in blocks of 8. Now I'm cheating a bit here because there's nothing stopping me going straight through this wall at the moment. It doesn't really know about the background, it just looks like it does because it's moving in blocks of 8. So that's our job really today, is to stop it being able to go through walls and detect that there's something there. So the way we're going to do that is we're going to write our own method, and we're going to call this canPlayerMove. So it's going to return a true or false, a 1 or a 0 if they can or can't move. And it takes the position we want to move the player to in the X and Y coordinates and checks them. So just write an empty method like that for now. And we're going to call that whenever we try and move the character down here, but we'll write some of the code up here first and then we'll show you how to do it. So we'll need to be able to work out which grid the player is in our background grid. So on our grid here, we need to know whether they're in this first grid 0, 0, or if they're in 1, 1, and we have to figure that out and work out whether there's a block in there. So the first thing we're going to do is actually figure out what index in X and what index in Y they're in from their X and Y coordinates. So we're going to need some integers, and these need to be int 16 or unsigned integer 16 because they're going to get bigger than 255 potentially, which is how many you can store in an unsigned 8-bit int. So we're going to have an index called index top left X. So that's the top left position of the sprite and what index in our background grid that is. Then we're going to have index top left Y. And then finally we're going to work out what tile index in our background array that refers to. So if you look back again at our tile map, each row has 20 tiles in it, and when it's actually saved out into maze map, each one of these is basically one of those tiles in that row. So if we went 20 along, that would be the end of the first row. And the number in here refers back to our sprites for our background. So this is the first sprite, which is the block. Some of these will have 0, 0, which is the empty sprite, the first sprite. One of them will have key and one of them will have door. So we're going to basically work out, is the index we're trying to move to, the kind of position in the array, is it empty, which the empty block is 0. So does it have a value of 0? If it doesn't have 0, then it's got something in it and we shouldn't go through it. So let's actually work those out. So we need to get the index of the X position for the player. So index top left X. And the way we're going to do that is we're going to get the new player location, the X location. We're going to get rid of that offset I talked about. So we're initially setting the player to be at 16 and really that should be 8. So we're going to take 8 off this. And then we're going to divide it by 8. So we're going to work out how many sprites, which are 8 pixels wide, down this player is. So if the player was at 8, it would be at the first index. If it was 16, it'd be at second index, etc. So that gives us the index for the X, and we're just going to do exactly the same for the Y. So we're going to hit new player Y. Again, the offset that this seems to have is it is currently set to 24, so we need to remove off 16 so that it would be back where we expect it to be at 8. And we're going to divide it by 8. So that's going to give us the coordinates in the background map along here. So if it was here, it's going to give us 1 for X and 1 for Y. If we were here, it's going to give us 1 for X and 4 for Y. Now we need to work out what tile index in the array, in the background map array, that is. So tile index top left, and the way we want to do that is our Y index is how many rows there are and our X index is how many columns there are, and we know from our background map that there are 20 sprites per row. So all we're going to do is do 20 times the index for the top left Y, so that will give us each row, and then we're going to add to that the index for the top left X. And because of how maths works, the times will get done first and then the addition will get done later. So if we were in this position here, we would have 1 times 20, 20 plus 1. So it would be index 21. Because don't forget the top left is 0. So we're going to look in the background map at index 21 to see whether that has an empty value in it. So to do that, we're going to get a result for that we're going to return. So I'm going to actually create a variable for that. So ubyte result, and we're going to use that down here. So we want to know if the index that we've worked out in the maze map. So maze map is here. If we go into maze map, you'll see it's an array of chars called maze map. So we can actually get the whatever array index we want from there. So if we do maze map, open bracket, and then put the index that you're looking for in there. So tile index, top left. That will get us the value that's at the index we've just worked out. And we want to know, is that empty? It's quite difficult to actually compare that to empty. So what I'm going to do is I'm going to create a member variable at the top here that's called BlankMap. And I'm going to introduce you to a new keyword today. So const is a constant, means it's never going to change. It will be more memory efficient if we mark it like that, because we know we're never going to change that. It's a data type of char. It's called BlankMap. It has there's an array of chars. It has one entry, and that entry is an empty hexadecimal, so 0 in hexadecimal, which if you look in here is this value. So we're going to compare what we get back from maze map at the tile index we're working out to see whether it's the same as BlankMap, the only entry in BlankMap, so it's 0. So if this index of maze map is 0x00, it will match our only entry in BlankMap, and then that will tell us whether we've actually got a solid block or whether it's empty where we're trying to move the character. So then we're just going to return result. We're going to come back to this and add a bit more in a moment, but we should actually start better using this. So if we go down to where our joypad is, we don't actually want to move the player. We want to test that we can move the player before we move them. So what we're going to do is inside each one of these, we're going to create an if statement. So if can move player, or can player move, sorry, and you put in the player location, and then however much you're going to move it in this statement here. So this one we would move the x location by -8. So we're going to pass in the player location in the x -8, and then the y doesn't get changed, so player location y. So we're going to pass those two in. It will work out whether where we want to move them has a blank or has something blocking them. If it's blank, it will return true. If it's blocking, it will return false, because we know we're looking for an empty one in our can player move. So then just put the actual moving of them inside that if block. So it now means if we hit left, it will test whether I can move 8 pixels to the left in the x coordinate, and if I can, it will actually update the player's location by minusing 8 from it. This minus equals we showed you in a previous video is a quick way of saying player location 0 equals player location 0 -8, and then we actually move the sprite, which is what we were doing before. So we can do that for all of these methods. And we just need to adapt what we're passing into player location. So this one is going to add 8 to it in the x direction. This one's going to -8, but it's in the y direction. And finally, this will add 8 in the y direction because we're going down. So if we compile that and reload our code, we get our map as before, and we can move down like we could before, but now we can't move left and right, and we can't move up. So it helps us navigate the maze. I can't go through walls, but also I can't go and pick the key up because the key isn't blank, so it won't let me touch it. And the same for the door. So we need to put something into our code that detects that we're at the key or detects we're at the door and does it differently. But before we do that, we're going to put a little bit of animation in, because at the moment it just jumps. It looks a little bit unnatural, and the player kind of doesn't feel quite in control. So we're going to show you how to animate those 8-pixel moves rather than do it all in one go. So the way we're going to do that is write our own version, pretty much, of move sprite so that it animates. So we're going to create a new function above. It's a void, does not return anything. Call it animate sprite. And into that we're going to pass the sprite index, so which sprite it is we want to animate, and then we're going to pass in how much we're going to move it by in X and how much we're going to move it by in Y. And because these can be positive or negative values, I can't use unsigned ints here, I have to use ints. So if you look at our code, we're only ever moving it either X or Y, we're not moving it in both, which makes the animation a bit easier, but we've got to work out whether we are moving it in one or the other, and we're effectively going to loop through moving 1 pixel at a time by however much we've been told to move it by. So this code at the moment is always going to move it by 8 in one direction or the other. So I'm going to write this with a few new bits of programming that I'll introduce you to try and keep it as small as possible. So the first thing we're going to do is use a while loop, but in this one we're going to first check moving in X direction. So we're going to do while move X is not equal to 0. So if I pass in a move in the Y and I pass in move X of 0, this is immediately going to equal 0 and then come out this while loop. So we're going to do the same thing for move Y. So basically this means I'll only ever do one at a time and it won't run both these pieces of code, it will only ever run whichever one is set. So we're going to scroll the sprite. Rather than moving the sprite, there's a function called scroll sprite, and what that means is you can just tell it which direction to scroll and by how much. You don't have to care about where the sprite is right now, because you'll notice we haven't passed in where the current location of the sprite is. So we're going to do move sprite, scroll sprite. We're going to go at the sprite index, and then we need to tell it to move in the X direction by however much we currently want it to. So what we're going to do here is show you a different way of writing if functions. So I could write this as an if function, but I'm going to show you a shortened way of writing if functions. So we want to know if it's moving negative or moving positive from our move X, because we either want to add 1 to the X location or minus 1 when we scroll it. So what we're going to do is say move X is less than 0. So if it's less than 0, move X must be negative. So we're going to use this special kind of condensed if function. So that's our kind of if bit, if move X is less than 0. Then we put a space and a question mark. And then the first thing we put after the question mark is what we want to return if that first statement is true. So if move X is less than 0, we want it to move by -1. Then we do a colon, and then we put what we want to return if it isn't true, which is 1. So this basically now says if move X is less than 0, then return -1, otherwise return 1. So it's a much quicker way of writing an if function, and it means I can use them kind of in line in another piece of code without it being too complex. And in this final one, when we're using scroll sprite, is the Y direction, and because we're only moving X, that will always be 0. So what this code is now going to do is it's going to check if move X is actually anything other than 0. If it is, it's going to loop round, taking -1 or +1 from its X position each time. So we now need to actually decrease or increase move X, either increase it up to 0 if it's negative or decrease it down to 0 if it's positive. So we're going to use that same clever if function. So we're going to do move X plus equals. We either want to take 1 or -1 from it. So we're going to use exactly the same as we did here, but flipped around a bit. So we're going to say if move X is less than 0, then we want to add 1 to it because it's going from negative to 0. Should be a question mark. Otherwise, we want to -1 from it. So this says move X equals move X plus, and then it does this statement. If we put it in brackets, it'll make it a little bit easier for you to understand. So the result of this piece here will either be 1 if move X is less than 0, or -1 if move X is more than 0, and we're adding 1 or -1 to move X. So it's basically going to then, as you go through the while loop, it's going to take move x. Say if it was 8, it's going to go 8, 7, 6, 5, 4, 3, 2, 1, 0, stop. If it's negative, it's going to go -8, -7, -6, -5, -4. You get the idea, and we can do exactly the same for the Y movement as well. We're going to put one other thing in here. If you're using scroll background or scroll sprite, you should really call the wait VBL done function. So that waits for the screen to finish before it continues. Wait for it to finish drawing before it continues. If you don't do this, you might have some weird kind of artifacts, some weird graphic glitches, so make sure you do that. So then we do exactly the same for the Y, just moving the difference between the two, so whether it's move Y, it's the same code, just repeated. So now when we call animate sprite, it will either move in X or it will move in Y, and I need to actually call that move Y. Okay, we've got our animate method, let's actually go and call it. So rather than calling move sprite, we're going to call animate sprite. We're going to pass in the sprite index, which is 0 because that's our character, and we're going to tell it which direction we want it to move. So in this case, we want it to move in the X axis by -8 and the Y axis by 0. Now we can get rid of move sprite. And we do exactly the same for all the others. That'll be +8. That'll be 0 in the X and -8 in the Y. And that'll be +8 in the Y. So if we compile and look at that. So now when we move our character, it should slide. So even though they're still only being able to move 8 by 8, it just feels more natural. We're not jumping in one go. It looks like they can kind of move around quite smoothly. It gives that impression they've got more control than they really have. Okay, so next, to actually make this game do anything, we've got to figure out whether the user is at the key or at the door. Now we could sit there and actually work out the index, exactly what's where, or we can put some debugging code in that will help us figure out whenever we want. So what I'm going to do, we don't want it on all the time, we just want to be able to turn it on. So we're going to have a U-byte called debug, and then we're going to turn debug on by pressing one of the keys. So we're just going to put something in here. If I press A, then set debug equal 1. Then what we're going to do in our can_player_move function is we're going to write out some of those values for the indexes so we can actually see what's going on. So I'm going to put a little bit of code here that says if debug equals 1, that you can just shortcut that to if debug because it will start, the default will be 0. So we can use the printf function, which prints out to the screen. The printf function takes a kind of format to start with, so this %u means that the character I want to write out is an unsigned int, and then a space, and then another unsigned int, and then a new line. And then the ints that I'm passing into it are the player X and the player Y. You have to do what's called casting them. So this is expecting an unsigned 16-bit integer, and these are only unsigned 8-bit integers. So you just put unsigned 16 in brackets beforehand, and it tells the code to turn one into the other. So I've done that, new player X, new player Y, and then it prints another line with 3 unsigned integers, which is the index for the top left, the index for the top right, and the tile index. So now if we compile that, if we navigate our player around to the key, and if we sit here and then we press A, if I go down, it will tell us what move was asked, what was can I move past. So it worked out that it was X index 1, Y index 16, which if you look at our maze makes sense, that's 116. And that index in the background map is 321. So we can go and look for 321 and do some special code, and knowing that that will be the key that they're reaching to. And we can do exactly the same for the door and exactly the same for the maze exit. So if I reset, we could go to the door here and we could go to here and figure out what those indexes are. So if we come back into our code, we're going to do this in can_player_move. So we're going to check if there are special indexes. So the first index we're going to look for is that key. So we're going to write it here. So if tile index equals 321, which is where the key was, then we want to actually collect the key. I'm going to write myself a little note. And then we want to make the key disappear and make it that I can actually go into that square. So to make it that I can actually go into that square, at the moment result is going to say that there's something there that isn't BlankMap. It's not going to let me go into it. So if I just change result to equal 1, that will say yes, go into it, because we know we can in this special situation. So when it returns here, it won't stop me going into it now. We want to actually record that the player's got the key. So we're going to have a uByte of has key. We're going to set that. So yes, they've now got the key. And the last thing we need to do is to change the background so that the key disappears. And the way to do that is to actually change what value is in the index currently in the background map. So we're going to set the background tile data at that particular position to now be blank rather than the key that's there at the moment. So set bkj tile, so set the background tiles, and we're going to start at our index, so the index in x and y that the key is at, so that was 1 and 16 if you remember, we had that in the debug. We're going to draw in the background tiles just one sprite, so 1 and 1, and then the value that we're actually going to give it is going to now be blank. We just want a blank map, so we can actually use what we use up here, BlankMap. So that's now basically updating our tile map that we loaded in previously, so that the tile index at 1 and 16 has this new blank map in rather than what was in there previously. So it's effectively it's going to go in to what we've loaded in memory from maze map, go and find the key, which will be in here somewhere, and effectively change the value for it in memory. So it won't change it here in this file, it'll change it in memory, but that's where the GameBoy is actually drawing it from. So at this special tile index of the key, change the background tile, mark that has key has been collected, and return a result so we're actually allowed to go into that tile. So if I compile that, and if I move around, so the key disappeared and it let me go into it, and we now know we've got the key. So now we can do a very similar thing for the door. So the door's tile index is different, and we can go and look that up, but I'll just do a shortcut for this. And we don't want to check both because we know we can only be at one index, so we're going to do an else if. So if the first thing doesn't evaluate to true, then try this. It will just be slightly more performant. So the tile index we're looking for the door is 263, but we don't want it to go into here if they haven't collected the key, so we're going to put an and in. So if it's at the door and they have the key, then we want to do something, otherwise we don't, so we want to open the door. So we're going to do almost exactly the same again. We're going to return a result of 1 so they can go through the door, and then we want to hide the door, so we're going to set the background tile again at the new location, and if you go and use that debug function you'll be able to look this up, but the new location is 3 in the X and 13 in the Y. We're only going to write one tile wide by one tile high, and we're going to blank it out again. And that will then let us through that tile because it won't be solid anymore. So now if we run it, it would let us go through the door. So we'll actually have a look at that. So first we're going to prove that you can't get through the door without the key. Won't let us through. So try it with the key. There we go. But now we want something special to happen when we actually exit our maze, and when we've kind of got out. At the moment I can just sit here and I can't do anything. So we're going to write another special tile index method. So again, we don't want to run it every time, so only if the other two above fail. And the index we're looking for the exit is 340. Again, I've used my debug function to look that up. and here we basically want to finish the game. So we both want to stop our while loop running because we don't want it to be able to move after we finish the game, and we also want to put some kind of message up for the user. So we're going to create a new unsigned byte called game running, and then we're going to make sure that at the top of our main method, before we go into this while loop, that game running actually is true, so it's equals 1. And then if they get to this special end game, we want game running to be equal 0. So when you start the game, game running will be true. When you get to here, it will be false. And then we need to change the while loop. So instead of looking for 1, we want to make sure that the game is running. So while game running. So that will then stop the player being able to move once they've reached that location, but we want some kind of message that comes up and congratulates them. So we're going to do a few things there. We also want to make sure they can get into this block. So again, set result equal to 1. So we want to print something to the screen. We've done this before. But the first thing we want to do is hide the sprites. We don't want to see our character anymore. We just want a nice clean you win screen. Then we're going to use printf again, which writes out some text to the screen. We're going to put a whole load of new lines in. It's important that you put the blanks in, otherwise those new lines won't actually register. And then we're going to write you win with enough spacing to make that appear in the middle of the Game Boy screen. So now if I actually compile that, and we go all the way to the end, there you go, you win, the game kind of finishes. So hopefully that's shown you everything that you need to do to kind of get this kind of game working. I've deliberately shown you what I think is the easier one, which is moving by 8 pixels. As I said, there are ways of doing it where you don't move by 8 pixels, you can move by individual pixels, but the problem with that is, if you imagine our user at the moment, if they could move a pixel at a time, they would have to be perfectly the right number of pixels down to be able to get through any gaps like this, and it gets especially tricky when you get to kind of T-junctions like this. You have to be in exactly the right place to be able to go down. Remember at the beginning where Zelda kind of did some fudging where it worked out that you could go down because that's what you were trying to do. And that's actually quite difficult to do. One way around that you can do is to make sure that your character sprite is much, much smaller than the gaps it's trying to get down. So if I just did this as like a 2 pixel wide sprite, it would be okay, the player could work that out. But when you have a sprite that's anywhere near the size of the gap it's trying to get down, it gets really annoying. So I would stay with a game simple like this where you're moving by the number of pixels in the sprite background that you're using. So it could be twice the size of this. Our sprites could be 16 by 16 and we could be moving 16 and it would look fine and work in the same way. So hopefully you've understood that. Please don't forget to subscribe and like this video and share it with other people. If you've got any questions, please ask them below. But that's all for now. See you next time.